Okay, pre-calculus kids, what we're going to do is section 7-5, which is the tangent and cotangent graphs, and learning how to do those. The rules change a little bit. What I want to do is review with you. It's been a little while since we did these, but the sine and the cosine graphs, quick review of what they look like. The sine graph kind of looks like this, where it starts at 0, 0, it goes up, it comes back down, ends at 0, a little more even than what I drew. Amplitude is 1. If I add inside with the x, if I add or subtract with it, it'll move it left or right. If I add or subtract outside of it, it would move everything up or everything down. If I put a multiplier in front of x, it'll change the period length. The normal period length, it starts at 0 and it ends at 2 pi. And then we shift that left and right or up or down, even flip it upside down. But this graph would be at 0, 0. Pi over 2 would be at 1. That's the highest point for the amplitude. When you get to pi, we're back to 0. 3 pi over 2, 1.5 pi. We're at -1. And then at 2 pi, we're back to 0. So it goes up, comes back down, bottoms out at -1. And then the wave would keep going. It would keep going this way as well. Okay, now for the other one, cosine has this kind of a look where we start from 0, we go to 2 pi. It sort of starts at the top peak, then it bottoms out, and then it ends at the top peak of the next wave. This one, amplitude is 1. There's a 1 out in front. The period length stays 2 pi, so we're going to go 0, 1, 2, 3, and 4, evenly spaced out, ends at 2 pi. Halfway would be pi, pi over 2, and 3 pi over 2. Cosine starts not at 0, 0, but it starts at 0, 1. And then it hits pi over 2 and 0. At pi, it hits, that should be -1. And then at 3 pi over 2, we're back to 0. And at 2 pi, we're back up at the top. And it kind of has this sort of a wavelength to it, going down and then back up again. So that's just a quick review of the sine and cosine graphs, because now we're going to move into the tangent graph here. We're going to move into the tangent and cotangent graphs. Let's make sure this is a little bit better. Focus. There we go. Tangent and cotangent graphs. You got to learn how to graph these tangent, cotangent graphs. Remember, the tangent function is an odd function. Okay, so how would you know that it's an odd function? Why would they say that? But it's an odd function. When it's an odd function, it's symmetric with respect to the origin. What that means is that it reflects diagonally when you look at the graph. I'm not sure how they're saying it, as if you would know that in the past, but I'm not sure where we brought that up in the past. But it is an odd function. The cosine is always going to be the x-coordinate, and the sine is always going to be the y-coordinate. It's going to be the y-coordinate. Tangent, we know, is the y over the x. We usually write it like this. The y over the x is how we usually write that. So let's think about the coordinates on the unit circle. Let's take the basic unit circle where the radius is equal to 1. Okay, so at 0, we're at 1, 0. At pi over 4 on the unit circle, we're at square root of 2 over 2, square root of 2 over 2. And then when we're straight up at the top at pi over 2, we're at 0 and 1. We're at 0 and 1. And then when we go negative pi over 4, it's a positive root 2 over 2, then divided by a negative root 2 over 2. I'm sorry, not divided by, but it's going to be x and y. And then negative pi over 2, going this way, negative pi over 2, 90 degrees backwards, so to speak. We're at 0, -1. Why are they highlighting just these? Why don't they go around the entire circle? Well, between pi over 2, or I should say, starting at negative pi over 2 and going up to pi over 2, start with the lower number to the higher number, that's where these wavelengths begin and end. For tangent, it starts at negative pi over 2 and it ends at positive pi over 2. It's going to start at negative pi over 2. It's going to end at pi over 2. They sort of throw this at you right away, and I'm sort of telling you in advance, hey, that's where it starts and that's where it ends for the wavelength. And then if we shift it left and right, when we did sine and cosine, it started at 0, ended at 2 pi. This is a period length of pi. Why is it these two numbers? Because of these coordinates and what happens when you do y over x. Watch. When you do tangent of 0, you got to do y over x. And when you do y over x here, it's 0 over 1, and that just equals 0. Okay? When you do tangent of pi over 2, when I do y over x at pi over 2, the y is a 1, the x is a 0. You can't do that. You can't have 0 in the denominator. So we call that undefined. When it's undefined, that gives you a vertical asymptote at, which one is this one? Pi over 2. So you can't actually plug that number in. It's not allowed. You can't plug in pi over 2 because it's going to come out undefined. So there's nothing that would show up on the graph. At negative pi over 2, you get almost the exact same thing. You go y over x, now you get negative 1 over 0, and you can't have 0 in the denominator. So again, it's undefined. That's a vertical asymptote at negative pi over 2. So that's what the tangent graph kind of starts and ends with. It starts with a vertical asymptote, and it ends with a vertical asymptote. All right, next one. How about when you plug in pi over 4? When you plug in pi over 4 and you do y divided by x, what you're doing is square root of 2 over 2 divided by square root of 2 over 2. Now, that's really an ugly square roots and fractions, but they're the same. It's going to equal 1. So at pi over 4, it's going to equal 1. We already did 0. It's going to equal 0. And then when we do y over x at negative pi over 4, the y is a negative square root of 2 over 2 divided by a positive square root of 2 over 2. That comes out to equal negative 1. And so at negative 1, we go here. This graph looks like an S curve. And then it would repeat itself. It goes every quarter. Okay? It starts at negative 1/2, and then it goes to a negative quarter. Then it goes to 0. Then it goes to positive quarter, 1/4 of pi. Then it goes to half of pi. You're going half a pi this way, negative, and half a pi this way, positive. The period is pi. And then it just repeats itself. You'd have another one like this, and another one like this. It would just keep on repeating itself over and over and over again. And that's what the tangent graph looks like. Every pi length, so the next asymptote would be exactly pi away from it. At pi over 2, the next one would happen at 3 pi over 2, 1.5 pi. This is at half pi. The next one's at 1.5 pi, so on and so forth. So unlike the sine or cosine, I did this wrong. So unlike sine and cosine wave, whose period is 2 pi, the tangent has a period of pi. Should read what I'm filling in at the bottom there before I jump to conclusions. All right, so to find the period of a tangent, what we usually do is, like, if I do tangent of 2x, instead of saying, hey, you take 2 pi divided by 2, that's when you do sine and cosine. The normal period for tangent is pi. So you go pi divided by the b value. All right? Whatever is multiplied by x. Whatever is multiplied by x. And that'll change what the period length would be. So if it did say 2 in front, and it's normally pi, then the new period would be pi over 2. It would only be half a pi. So it would go 1/4 pi to the left and 1/4 pi to the right. Altogether is pi over 2 in length. Okay? The tangent graph will normally rise when you look left to right. It's going up left to right. All right? A negative, in front of amplitude would flip it upside down. So if there was a negative in front, the whole thing would spin upside down, and then the left side would be up and the right side would go down. So pay attention if there happens to be a negative in front. We've done that with other graphs in the past. Let's talk about cotangents. Well, I'm going to get started on cotangents. I can see my time's going to run out. We got a couple of examples to do as well. All right, cotangent graph. The graph of the cotangent function is similar to the graph of the tangent function, graph of a cotangent function. Remember, the cosine is always the x-coordinate, and the sine is always the y-coordinate, okay? Since cotangent is the reciprocal of tangent, it's represented as the x over the y, the other way around, x over y. Well, that changes when it's going to have asymptotes and when it's going to be undefined, so to speak. So it changes things up. All right, these all say tan, but they should all say, let's cross that out. They should all say cotangent. Cotangent, 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 tangent, and cotangent. So I think somebody did a little copy paste when they typed it up, and they forgot to change it over to cotangent. So we're going to talk about the tangent, cotangent of each one. So the cotangent of 0. The cotangent of 0, now we got to think of the x over the y. So look at the unit circle. They're doing 0, pi over 4, pi over 2, 3 pi over 4, and pi. It's going to look like this. It's going to be 1, 0, then square root of 2 over 2, square root of 2 over 2. And then it's going to be 0, 1, just like what we did in the first quadrant on the other page. For 3 pi over 4, it's going to be a negative square root of 2 over 2 for the x and a positive square root of 2 over 2 for the y. Remember, it's at 45, 45, 90 reference triangle. And then this one's going to be at negative 1, comma 0. Then it would sort of repeat itself. We'd have the same pattern of values. But take a look at how this one works out. So if I go x over y, when I do cotangent of 0, right away I'm going to get 1 over 0, which is undefined. All right, so there's a vertical asymptote at 0. There's going to be a vertical asymptote at 0. Put a big old 0 in there. All right, the other vertical asymptote, you can already tell by the way they did the notes down here, is going to be at pi. If I go x over y, I'm going to get negative 1 over 0. And we're not allowed math to have 0 in the denominator. So that's undefined. So again, a vertical asymptote at pi. Not 2 pi, but at pi. That's the ending of this period length. It's going to go, these are going to go from 0 to pi, where tangents go from negative pi over 2 to positive pi over 2. So 0 is sort of like the middle of the tangent graph. The middle of the cotangent graph is going to be halfway in between. It's actually pi over 2, just like up here, halfway in between, pi over 2. So at pi over 2, what I get is x over y. That's a 0 over 1, which is 0. Okay. At pi over 4, I get square root of 2 over 2 divided by square root of 2 over 2. Oh, hold on. I got to pause right here. Jump over to the second video to pick it up from here.